let's talk about how we find the derivative of e to the x. Now, the first thing to know about e to the x is that it's its own derivative. But because we could put other functions or variables or something into this function, our basic derivative is to find the derivative of e to something. We begin by just having e to that thing back because e is its own derivative. But then because of chain rule, we might multiply by the derivative of whatever that exponent was. So if we started with the basic and we just said, well, the derivative of e to the x, well, e to the x is its own derivative, and then multiplied by the derivative of that exponent, well, the derivative of x is just 1. But if we said, well, what's the derivative of e to the x cubed? We'd begin by saying, well, it's e to the x cubed, but then we have to multiply by the derivative of that exponent, x cubed, so 3x squared. And you'll usually see these written with the power stuff first and the exponential last. Of course, the order doesn't matter, but that's usually how you'll see it. If we said, what's the derivative of e to the x squared plus tangent x? Maybe I'll put that in parentheses so we see it's all part of the exponent. We'd begin by saying, all right, well, it's still e to the x squared plus tangent x, but then we would multiply by the derivative of that exponent. So the derivative of x squared and the derivative of tangent. So again, just always remember that to find the derivative of e to something, we begin with that same e to the something, because e is its own derivative. But then because of chain rule, we may have to multiply by the derivative of whatever that exponent was. If this video helped you, please like and subscribe for more math help.